Welcome back, everybody. So today we're going to be talking about exercise 5.2.20. If you know how to do the question, if you solved it successfully, you don't have to watch this video. This is only for those who weren't able to do it. Okay, so the first thing is I'm just going to read the problem. It says a light shines from the top of a pole 20 meters high. Okay, so here's the light in my diagram, and the pole seems to be 20 meters high. An object is dropped from the same height from a point 10 meters away. Okay, so actually the object is maybe dropped from here, from the same height, but then at some point it, falls and it reaches here. So the object's trajectory starts here and it kind of falls until it hits the ground. It says the object is dropped from the same height from a point 10 meters away. Okay, so the distance between the light and the object is 10 meters, so that's 10 meters. And also it says the object has a height that's described by a function of time. So it's 20 minus 9.8 t squared divided by 2. I'm going to divide by 2 right away. So this is actually 20 minus 4.9 t squared. Okay. So what this is saying is this guy here, the height of the object at any point t, is described by a function of time, h of t. Okay, so it's important to keep in mind this value is constant. Okay, so the light is at a fixed height. This is constant. The object is always a fixed distance away from the light. This is variable. The object is kind of falling down. And then it says, how fast is the object's shadow moving on the ground 1 second later? The hardest part about this question is determining what this last statement is even saying. So it's saying it wants how fast the object's shadow is moving. Before you can find how fast the object's shadow is moving, you have to locate where the shadow even is, okay? So the way we locate it is this is the light, this is the object. The light will cast, the light's rays are kind of being emitted, and the shadow is going to be cast right here because this ray coming from the light towards the object will never meet the ground, and so it'll leave a shadow right here. So you have to kind of recognize that this is the shadow. Once you recognize that this point right here is where the shadow will be of this light on this object, once you figure that out, you got to figure out how fast the shadow is moving 1 second after it's dropped. So the shadow, one thing that you should do, and it's a good idea to always do this, is to think about what happens as this object moves up and down. Well, as the object, so it starts here, in which case actually it would have no shadow because the light's rays would kind of go this way and miss. So as the object falls, the shadow is going to be moving. So let me draw some lines so you can see. Okay, so say at some time later, object falls so that now it's here. Shadow will be here. And then say at a later time, object falls a little bit more here. Shadow's here. And then so on. This will keep happening. So at the end, when the object meets the ground, I guess there wouldn't be a shadow, or maybe there would be, and it would be the same as the object. But anyhow, the idea being that the shadow is moving in this direction as the object falls down. And you need to kind of have a mental picture, and walking through some specific cases can help you build that mental picture of what's happening. Okay, I'm going to get rid of all this. Okay, so we know that the shadow is kind of moving in this direction, so I'll indicate that like this. Okay, so there's movement in that direction of this shadow. And then the other thing I want to do is describe the shadow's length. So I'm going to call this S, and you could do it from any point. Honestly, it doesn't matter. You could say, oh, I want this to be my reference point. So I'm choosing this to be my origin or my reference point. But you could choose this to be a reference point. The object where it hits the ground could be the reference point. It doesn't matter. The important thing is like you have a length that kind of represents how far the shadow is away from some fixed point. And then as the shadow moves, this length here, this length is going to decrease. So when it starts out, it's here, but when the object hits the ground, it's going to be here, the length. Okay, so this length is going to decrease over time. Okay, so the next thing is, let's write down what we want. What we want is the rate of change of the shadow's length with respect to time By the way, you should always define it. I know I'm not doing a good job defining my variables, but like, for example, S here, you should say let S be equal to the distance of the shadow away from our reference point or origin. That way it's clear to the reader what S represents, okay? But hopefully it's clear from the diagram that I've drawn. So ds by dt, we want ds by dt, which is the rate of change of the shadow's length with respect to time. And it's going to be negative because the length of the shadow is shrinking when t is equal to 1 second. Okay, so how are we going to do that? Well, this problem, what we're going to be doing is we're going to be finding some similar triangles and use those similar triangles to help us with the problem. Okay, so what I'm going to do is project from the object. I'm going to make a projection from the object towards the light, and that will be our right angle. This is our right angle, this is our right angle, so on. Okay, so this outer triangle, I'm going to say the ratio of this side to, oops, let's do that in black. The ratio of S to 20, so the ratio of this side to this side is the same as the ratio of this side to this side. Okay, so that's equal to the ratio of 10 to, now here you have to be careful, this length here is going to be 20 take away h. Okay, so this length here is 20 minus h. H is a function of t. Okay, something like that. Now, by the way, the reason these are similar triangles is because this angle is the same as this angle. The reason those two angles are the same is because these two lines are parallel. Okay, so these are corresponding angles along the traversal. And then this is a right angle and this is a right angle. So because these two angles and these two angles are the same, you have a situation where you have two similar triangles by angle-angle postulate. Okay, so this is the equation. And then what we just need to do is simplify. First thing I'll do is maybe just replace h of t with its function. So h of t is 20 minus 4.9 t squared. So 20 take away 20 is going to be 0. And then when we take away the negative 4.9 t squared, it's going to be positive 4.9 t squared. Okay. And then I'm going to choose to, what am I going to do? I'm going to multiply both sides by 20, I think. So we get 200 on the top divided by 4.9 t squared. And then I'm gonna, I think, move the t into the numerator like that, like a negative exponent. And then I'm gonna take the derivative with respect to time of both sides. So we get negative 400 divided by 4.9 t to the power of negative 3. And then I'm gonna evaluate this when t is 1, okay, because that's what we want. When t is 1, we get negative 400 divided by 4.9. I'm going to quickly plug this into a calculator, and you can do the same. So if you do that, I'm getting something like negative 81.6. Units here are going to be, if we go back to the question, it's in meters, and the height also seems to be in meters, and the time is in units of seconds. So this will be in meters per second. Now, because this is negative, because this length here is actually shrinking over time, so it's going to start off here, and then at its minimum, it's going to be here. So that's why it's negative. But the question is just asking for the speed of the shadow, I think. Let's see. How fast is the object shadow moving? So because they want the speed, you can just ignore the negative sign, and you could just say the shadow is, moving towards the right. Therefore, the shadow is moving right at 81.6 meters per second. Okay, so that was question 5.2.20. Hopefully that's helpful. If you had trouble with this question, what I encourage you to do is try a similar problem. Try 5.2.19. I think it's about a helicopter or something, kind of similar. You can understand my explanation, but until you do the questions yourself, you're not going to learn the skills that you need to, okay? So please try this on your own if you struggled with this, and then that will be a good way to apply what you've learned in this video. Okay, bye-bye.